Another use of definite integrals is when we're looking to try and find the area between two curves. Now, we already know that the definite integral from a to b of a function represents the region between the function and the x-axis, starting at x equals a and ending at x equals b. Right? But what if we had two or more curves, and we were looking to find the area between any two of them over a particular region? How could we go about solving that? All right. In other words, here's two functions right here, f and g. All right. F is above g, f is greater than g, over the interval from a to b. And you can see that region shaded in red. And the question comes, well, what is that area equal to? How can we find that area? All right. And I would encourage you to pause the video at this point and think about it in terms of each individual function. How can we find the area between these two curves? Hopefully you did take a chance to pause the video, and if so, you realize that, you know what, if I want this red area right here, well, I need to find two areas, in fact. I need to find the area of the region below the purple function, which would be this region right here. But that's obviously too large, because that takes up the entire region, but I don't want this lower region right here, the region that's underneath G. Well, the region that underneath G is this green region right here. Right? So if we were to, in fact, take, let's mark this down, the larger region and subtract the area of the smaller region, we would end up with the region in between the two functions. And that's what we're looking to do. Right? Now, this purple region right here, isn't that the integral from a to b of f of x dx? Right? And we're subtracting it from, subtracting from it rather, this green region. Now that green region is also a definite integral. Its area from a to b, but this time the function is g of x dx. So we're just going to subtract the g area from the f area. F of x, integral from a to b of f of x dx minus the integral from a to b of g of x dx. That's going to give us the region that we're looking for. Okay, but this has two integrals, which is perfectly fine. But we can also merge it into one integral because we have two integrals separated by subtraction. So if we want to actually put it into one integral, we'll have the integral from a to b of f of x minus g of x. All right, we can subtract the two functions, and then we just need a dx for everything. So we'll wrap this in parentheses and give it a dx. And this right here is quite often what you'll see when you're looking for formulas for the area between two curves. Now, the one thing about this, though, is we have to keep in mind that the f function has to be the larger function. So f needs to be greater than or equal to g on the interval from a to b. All right, we need that stipulation right there because if g is above f, well then now g would need to go first and f would need to go second. The larger function always goes first, which is why quite often we see, oops, that should be an a, there we go, integral from a to b, we just say top equation minus bottom equation. You can remember it in that regard, all right, top minus bottom. And it doesn't matter if that region is above the x-axis, if it's region straddling the x-axis, or if that region is below the x-axis. The greater function is always the top function. So the integral from a to b of top minus bottom would also, another easier way to remember your formula for the area between two curves.